What if the future of flight didn't come from aerospace giants, but from a physicist who once broke speed records on a human-powered bicycle? Welcome to Industry Ignited, the podcast where we explore the leaders and innovators shaping the future of industry and technology. I'm your host, Dr. Leeanne Aguilar, and today I'm joined by Damjan Zabovnik, Chief Executive Officer of EV Corporation, a company developing next-generation electric vertical takeoff and landing aircraft and heavy-lift drones. Damjan is a physicist, inventor, entrepreneur, and out-of-the-box thinker whose hands-on experience spans aerodynamics, rapid prototyping, UAV systems, autonomous flight, and AI. Damjan, welcome to Industry Ignited.
Thank you for having me.
Now, you spent over a decade breaking speed records with human-powered vehicles. How did that experience shape the way you think about aerodynamics and efficiency today?
Well, I always like to experiment, and that was the best test on the field about aerodynamics. And I enjoyed it. It was a lot of determination needed, not only to build the bicycle and design it, but also race it. So a lot of responsibility, being on time for the race. And I enjoyed gathering data from the field. We were even in wind tunnel once and confirmed the data. And we basically know how much human can produce power, how much power we give out. There's really, the cheating is impossible. You can't say this bicycle is very inefficient. You are actually producing 1000 watts, because that would be impossible for human. Human can go, for me it was like 250 to 200 watts continuous power, and if you can go like 54 miles speed at that power, that tells you that the vehicle is really aerodynamic and efficient. So it was a great experience to see how physics can change things for the better.
Wow. Now, yeah, and you showed me pictures of the bicycle that you were actually riding. And tell me a little bit about the design and how you got it to go so fast.
So first, I need to tell you that these vehicles are most aerodynamic vehicles in the world. If you have cars, they have four wheels, they have wider wheels. Tire is more exposed usually. If you have airplanes have wings and they need to lift, and lift causes energy penalty, right? So land vehicle can be more aerodynamic, and two-wheel vehicle is very aerodynamic. And if you look like a fish, like a torpedo or what else I can compare to, that's really very, very good. And we used a lot of laminar flow, so the nose was prolonged, where laminar flow can be maintained and produce less friction over the surface. And then a little shorter tail, where friction to surface gets bigger, and turbulences begin in transition from nose to tail. So it's an art to what looks nice goes fast too. Not always, but commonly that's true. So it's a little bit of art, a lot of physics, and enjoying building those vehicles. And then you need to train a lot to be also in good performance, because it will be a waste of time if you don't have power, but best vehicle. So all had to fit together. It was a battle, challenging to get good weather and everything else that goes to the race to fall in place, I reached a world record after like 10 attempts of 1 hour.
Wow. Okay, 10 attempts.
Official attempts. Yeah.
What was the world record?
The world record was 54.1 mile in 1 hour from standing start.
Well, congratulations. Now that's an incredible accomplishment. Now, you're a physicist by training, but also very hands-on in building and prototyping. How did that blend of theory and practice shape your path as an inventor?
I believe it's a very good experience if you can make something, if you know how to build it. Because by default, you avoid designing something that can't be built. And you tend to simplify everything, which is good also for reliability of a design. If it doesn't have too many moving parts, if it's easy to build, it will be difficult to just fall apart and stop working. In usual, it's true that simple innovations are good innovations, and that's what I try to do. Most of what I've done in my life was around efficiency, whether transportation or some buildings that have very good thermal insulation, and other stuff like energy interests me a lot too.
Yeah. So just keeping designs that are just very simple, so it's efficient and not too many moving parts that can break or cause inefficiencies, is what I'm hearing. What was the moment you realized your work could move beyond bicycles and into aviation and vertical flight?
So what was inspiration was my friend Gabe, who played with drones, and also Joby Aviation, who wanted to make human transportation more efficient by air taxis. And that VTOL inspired me to try for VTOL design and do it my way. It was back in 2014, 2015 when I started to play with VTOLs. Well, later only in 2021, when I met some other people who are in aviation pretty for a long time and wanted to go for one special competition, Go Fly Personal Flying Device Challenge. Then in 2021, we started to prototype and used my design as basis, and then improved the design and patented it and so on. So business started to develop.
Okay. And for listeners who aren't engineers, how would you explain EV's circular wing VTOL concept and what problem it solves compared to traditional helicopters or drones?
So circular wing is something that you cannot see in the nature, but also you don't see in the nature vertical takeoff and vertical landing. That's very unusual. So we can't expect that the aircraft, perfect VTOL, would look like a bird. Like you said, I think out of the box. I wanted good efficiency in vertical flight, so I used two big propellers to give you more lift and bigger efficiency. And now if propellers are really big compared to the wing, where to put the wing, right? The best solution to me appeared that the wing needs to be circular, so the air can come to propellers from above through the hole of the wing. And that was really basis that I kept all the time. At that time, I wanted only aerodynamic surfaces, no more motors than two motors, or three, actually two for vertical flight, two big propellers on them, on each of them, and then one in the back to push aircraft forwards. Later, I changed my mind and used at least four motors, two in the back, two in front, no control surfaces for vertical flight. So I'm going into details. Your question was, why circular wing? Also, when you fly horizontally, circular wing is not cantilever, it's not unsupported at the tips, right? If you look at circle, it supports itself all around. It's a structural thing. And if you want to fly heavier, and by the wing needs to be structural. So this circle also is very compact solution. It's smaller. For the same wing loading, you can end up with smaller wingspan of aircraft. This also means that you will be able to park it in smaller spaces or take off and land into smaller places and transport it by other transportation, right? If you put it on train, it will be smaller, easier. A conventional aircraft removes the wings for transportation, but that's additional work. The idea is to have it, if this is one person. I started with idea to have a personal commuter for one pilot. The idea was to fit into a garage, like a flying car would. But this is not a flying car. I didn't want to create something with the wheels to be either on the road or in the air. The idea was always to go from point to point flying, and then if you want to move on roads, you use a scooter or anything that is at hand. This way, you can avoid of additional weight on the aircraft to provide street, propulsion and going down the street.
Yeah. So like a really compact solution that,
Yeah.
So it's versatile. You can fit it in and out of a lot of different spaces, and that's something that's really efficient. And now I know you went through like 6 or 7 major design iterations to start with. What did those early failures teach you that directly influenced your current design?
Well, there was an interesting realization when I tested that first prototype with control surfaces in vertical flight. There were control surfaces below propellers to vector air left, right, forwards, backwards, and impact, roll, and pitch. If there was a lot of side wind, it tended to crash. And I didn't want to add extra surfaces above the aircraft to counter side winds. That helped, I measured. So it was like either you make it very stable and slower or unstable and faster. And there was not a very good solution for what I wanted to build. So we added propellers, like multicopters have more propellers, right, around to control the attitude of the aircraft. And that seemed to be the right decision. We still kept efficiency. And by the way, the circular wing also protects the main propellers. If you bounce anything on site, it will protect them. And that's the most important. That's the main source of lift. You don't want to break the big propellers. What taught me was that I need to try. And even though crashes happen, they taught me a lot. So there's no linear straight up progression. You go back and forward and backwards again with progress. Yeah. It's frustrating many times. But with the hope and confidence that you can solve it, you don't give up. And persistence is important, I would say.
Right. Yeah. No, I hear that. And that progress isn't linear. It's like you said, it's lots of ups and downs, 3 steps forward, 1 step back. But I guess the biggest thing is that perseverance. Just keep moving forward till you figure it out.
But you shouldn't be stubborn. Also, you need to listen to any idea, and if it's the right, implement it, even though you are not originator of it. That wise approach is very important too, and being flexible.
Were you working with a team for the development, or were you doing most of the...
I had an aviation designer and drone engineer with me at the very beginning, and later got airspace engineer and business developer and people in different areas.
Yeah. Now, your aircraft blends helicopter-style lift with fixed-wing efficiency, like you're mentioning. Why is that hybrid approach so powerful for heavy lift and long-range missions?
So, any VTOL that wants to be efficient in horizontal flight needs a wing. That's given. If you look at helicopter that doesn't have wings, helicopters mix way more air to produce the same amount of lift. They mixing, when I say mix, there will be a lot of turbulent airflow around helicopter, which is just pure loss. It's chaos. Turbulence is chaos, and that's inefficient way of flying. If you use laminar flow over the wings and fuselage, that gives you order. Its molecules in the air are more ordered and create less friction between each other. It's like a group of people. If they have frictions between themselves, overall progress of the team will be low. If they push in the same direction, they are efficient, right? The same in aerodynamics. So horizontal flight efficiency, you need wing. If you look at vertical flight, you want bigger propellers and not too fast rotating propellers. So load on propellers is not that big. And the same, it's connected with efficiency, how much of energy can really be put into thrust, how much power, and how much of that is lost in chaotic movement of air. So for that reason, I started with biggest possible propellers. They're almost the same diameter as the size of the aircraft. And I could measure that it was always a little bit more efficient than smaller propellers on quadcopter or multicopter. And also there's another reason. if you park two propellers in horizontal flight, those two propellers parallel to airflow, to direction of flight, they will not create much wind resistance. So you'll get better lift to drag ratio. You will spend less power for certain speed. But in contrary, if you have many propellers and they are supported with some arms that are not parallel even to direction of flight, all those arms and small propellers and motors exposed to air, all that will create way more air drag.
How many propellers does your drone have?
So it has from 4 to 6. 2 variants is what we went for so far. 4 propellers means 2 in center and 2 in the back. And only 2 in the back control pitch and roll in vertical flight, while center propellers, big propellers, take care of yaw control because they are counter-rotating. Or 6 motor variant means that you have like quadcopter with small propellers more far apart, but in between them are 2 big propellers that create most of the lift.
Okay. Now, one of your first target markets is emergency and first response operations. Why is this the right entry point for EV's technology?
Well, we've been thinking about many niches, entry points, and we realized that today there are so many needs in emergency response. We had wildfires, we have floods all over the world, we have different wars which do casualties of civilians and soldiers which might be rescued, or wars ignite wildfires again. So to rescue people or improve quality of life, it seems that we will have first customers in rescue, either in wildfire or remote hospitals, remote communities, or just after natural disasters, different, or war. We have letters of interest from Ukrainian government right now, and several from California. And there is need for supplying oil rigs, which can be 30 or 100 miles away from shore, windmill, power plants. It seems that the drone that can lift from 300 to 500 pounds roughly is very needed today. So we don't have any doubt that our product will be well sold when it's ready.
Yeah, because from what I understand, your product can carry a lot more than a traditional drone.
The given size, definitely, it can carry a lot.
Now you're integrating onboard AI so the aircraft can detect and respond to events like wildfires without outside connectivity. Why is autonomy at the edge so critical?
So in disasters, especially if they happen in remote areas, we don't have cell towers. So how would you navigate a drone? How would you take data off? It's either satellite or long-range antennas. Our drone has capability of putting very capable antenna inside the circular wing, which can use array of elements and be directed antenna. That high gain enables high bandwidth of transmission of data. But why autonomous? Even though everything is connected, sometimes things go wrong. But the wildfire is already burning, right? So if the drone can autonomously decide how to extinguish that wildfire as soon as possible, when it's very small, it's better than to depend on connectivity to cloud, to outside AI, and act in that manner. It will act more smart and with bigger certainty, but probably as soon as you cut off that, it's helpless. And, to be more efficient on edge computing is very important.
Yeah, that makes sense, especially if you're in environments where you might not have regular connectivity.
Sometimes drones are intentionally jammed, and we want to have a solution that is redundant.
Yeah, that makes
and
sense, especially if
resistant
it's,
to that. Yeah.
yeah, that makes sense. Now you've received a NASA SBIR
Mm-hmm.
Phase 1 award, from what I understand. That's exciting. And interest from international partners, including Ukraine. What kind of validation does that provide at this stage?
Oh, it's huge. Things started to move way faster after we got this grant. And now we really need to decide in which direction to go. There are so many opportunities. Before, it was like, yeah, you might be just an artist who doesn't know what he's talking about, right?
Right.
A novel design, they look at it more with more skepticism. And if it's only no, no, no from any partner or investor, it's frustrating. So things
Sure.
improved. Yeah. It gives
Yeah.
us credibility.
Yeah. That makes a lot of sense. When did you receive that award? How long has it been?
Officially, we got awarded in September
Okay.
this year.
Yeah.
Mhm.
So more recently. Very
Yeah.
exciting. Now you're building a highly complex space, which is in aviation, autonomy, and defense adjacent technologies. What has been the hardest leadership challenge so far?
Well, I got a co-founder back in April this year, maybe March. So accepting a co-founder is like a marriage in life. It's very serious, and it was hard for me to really accept it and decide for it. But I think it was a right decision. Otherwise, choosing the design that you keep developing and leave behind the designs that seem nice but not so promising, that's a hard decision too, because once you stop testing a design, you probably never come back. It's it pulls you into new thinking and new design. It's probably a one-way street.
So what led you to decide to bring on another leader into the organization?
It's easier to get funded, and also me myself, I need a person who complements me. I'm a generalist, but still I need specialist in some fields that are really important, or some fields I don't cover at
Right.
all. So it's much easier when I need to go somewhere, make some meetings. He can at the same time answer some questions that need to be answered and be available to customers or investors or
So new set of
employees.
skills. Yeah. So broaden your capabilities and then also support is what
It's a
I'm
dilemma,
hearing.
Two
Yeah.
co-founders, they easier get into arguments and break up the company. But
Yeah.
one co-founder as well, many founders, many investors don't like that because it depends too much on one. And
Right.
if I, God forbid, get injured or killed or something, everything could be stopped. But with another co-founder, it's possibility that the investment that is in the company will bring a return on investment in the future anyway.
Right. And that makes sense. Yeah, too much risk with just a single owner. So bringing somebody else on board disperses that or minimizes that risk. That makes sense. Now, as a founder, husband, and father, how do you balance long-term vision with day-to-day execution and family life?
I am fanatic by heart. It's hard for me. It's more easily for me to get obsessed with something and really working only to that matter than to be well balanced and being with family enough. I have problems. I need to improve in that, but I'm aware of it. I can balance it somehow. So far, so good, I would say.
Yeah. And I think that's common, especially people who are very passionate about what they're doing. It's easy to get that tunnel vision and to focus. I mean, I know I've been guilty of that myself, too, really getting into a project and just lose sight of everything else that's going on around me. Important to be, I think, like you said, that awareness, being aware of it.
I am
just
able to go for as long as needed until the long time expected goal is achieved, And many people around me look at that as I was crazy. What do you see? What about this little thing here and that little thing there that I just neglect, right? I am looking into long-term results. It's hard to explain, but that's how I am. But I have big endurance.
Yeah, That makes sense. Now, for engineers and innovators listening who have unconventional ideas, what advice would you give them about taking bold risks and staying persistent?
I would say it's not easy, but the joy that comes out of having success, I mean, when I set the world record, I was the most happy ever in my life.
Yeah.
You never forget this. So these are the things that is worth living for, right? And even if it's really hard, to me, it's still a way of choosing my life to live freely. If I can do what I really love to do, that means a lot of freedom to me. So it's worth trying, even if you don't succeed. And in what you want, it's risk management. You hope for the best, and there are battles, right?
Mm-hmm.
You lose battles, but at the end, usually, if you really go for what you believe you are made for, I believe the war will be won at last. And it's don't give up and keep digging, I would say.
Yeah, absolutely right. Because if you don't give it a shot, for sure you won't win. So that's for sure. But if
Quitters are not winners. That's it.
Yeah, absolutely. Well, Damjan, thank you for sharing your journey, your vision, and the groundbreaking work you're doing at EV. For listeners who want to learn more, how can they find out more, follow your work, and learn about your technology?
So it is website eivie.us, and you can find me on LinkedIn, and we can go from there.
Great, thank you. And for listeners, if you enjoyed this episode, be sure to subscribe and tune in for the next conversation. Until next time, stay bold, stay curious, and keep igniting industry.